In the vast expanse of our universe, there exists an object so powerful, so enigmatic, that it challenges everything we thought we knew about reality itself. Picture a cosmic titan with gravity so intense that not even light, the fastest thing in the universe, can escape its clutches. A place where the very fabric of space and time becomes warped and distorted, where time itself seems to stand still. This is a black hole, perhaps the most fascinating and mysterious object ever discovered by humankind. These cosmic behemoths have captured the imagination of scientists and dreamers alike for generations, and for good reason. They represent the ultimate expression of nature's power, where the known laws of physics are pushed to their absolute limits. In a black hole, the conventional rules that govern our universe begin to break down, giving way to phenomena that seem to belong more in science fiction than in reality. Yet they are very real, and their existence has been proven through decades of astronomical observations, and more recently, through groundbreaking direct imaging. Today, we're embarking on an extraordinary journey into the depths of these cosmic giants, peering into their darkest secrets and uncovering revelations that continue to astonish even the most seasoned astronomers. What we've learned about black holes in recent years has surpassed even the wildest imaginations of science fiction writers. From the discovery of supermassive black holes lurking at the centers of virtually every large galaxy, to the detection of gravitational waves from colliding black holes, to the first ever image of a black hole's shadow against the bright backdrop of space. Our understanding of these cosmic monsters has experienced a revolutionary leap forward. As we prepare to dive deeper into the mysteries of black holes, I invite you to join our growing community here at Exploring the Universe. Just as the gravitational pull of a black hole allows nothing to escape its grasp, you won't want to miss any of our upcoming videos about the cosmos and its endless wonders. Our channel is dedicated to unraveling the greatest mysteries of the universe, bringing you the latest discoveries and most fascinating phenomena that space has to offer. Subscribe now to ensure you're part of this cosmic journey, as we continue to explore the furthest reaches of space and the most extreme objects in existence. The story of black holes is one of nature's greatest mysteries, and we're just beginning to understand their true significance in shaping our universe. From their violent births in the deaths of massive stars to their crucial role in the evolution of galaxies, these cosmic giants continue to surprise and amaze us with each new discovery. So join us as we venture into the darkness to find enlightenment about these remarkable objects that have forever changed our understanding of the cosmos. To truly understand the birth of a black hole, we must begin with a tale of cosmic death, the spectacular end of a massive star. This isn't just any ordinary stellar death. It's one of the most violent and transformative events in our universe. These cosmic giants, born with at least 20 times the mass of our Sun, live fast and die young, and their deaths give birth to something extraordinary. Picture a colossal star, burning bright in the darkness of space. Throughout its life, this celestial behemoth has been maintaining a delicate balance between two opposing forces: the crushing weight of gravity pulling inward, and the immense pressure from nuclear fusion pushing outward. Deep within its core, hydrogen atoms have been fusing into helium, then helium into carbon, and so on up the periodic table, creating increasingly heavier elements. This process releases the tremendous energy that keeps the star from collapsing under its own weight. But nothing lasts forever, not even stars. When such a massive star exhausts its nuclear fuel supply, the consequences are catastrophic. Without the outward pressure from nuclear fusion to counteract gravity, the star faces an inevitable collapse. This isn't a gentle, gradual process. It's an extremely violent event that happens in mere seconds. The star's enormous mass, which once made it shine so brilliantly, now becomes its undoing. The collapse begins at the core. As the internal nuclear furnace sputters and dies, the star's immense gravitational force takes over. The core, no longer supported by fusion pressure, begins to implode. The pressure and temperature become so extreme that even atomic nuclei are crushed together. This implosion happens with such incredible force that the star's core is compressed beyond anything we can comprehend in our everyday experience. What happens next defies our understanding of physics. The core continues to compress until it reaches a point mathematically known as a singularity, a point of infinite density where space and time as we know them cease to make sense. The gravitational pull becomes so powerful that it warps the very fabric of space-time around it. A boundary forms in space, known as the event horizon, marking the point of no return. Beyond this boundary, the gravitational pull is so extreme that nothing, not matter, not light, not even information itself, can escape. Meanwhile, the outer layers of the star, reacting to this catastrophic core collapse, are blown outward in one of the most energetic explosions known to science. A supernova. This explosion briefly outshines entire galaxies, seeding the surrounding space with heavy elements forged in the star's death throes. But at the center, something far more mysterious remains. A newly formed black hole, a cosmic monster born from stellar death. This transformation from star to black hole represents one of the most extreme physical processes in our universe. It's a reminder that in cosmos, endings often mark new beginnings, and death can give birth to some of the most fascinating objects in existence. The black hole that remains will continue to influence its surroundings through its immense gravitational pull, potentially affecting the evolution of its entire stellar neighborhood for billions of years to come. Let's dive into the seemingly impossible anatomy of a black hole, breaking down its mysterious components in a way that makes these mind-bending concepts more approachable. Understanding the structure of a black hole is crucial to grasping just how extraordinary these cosmic objects truly are. The most famous feature of a black hole is its event horizon, a boundary in space that represents the ultimate point of no return. Think of it as nature's most extreme one-way street. To understand this concept, imagine standing at the edge of the world's most powerful waterfall. Just as water flowing over the falls can only go in one direction, down, anything that crosses the event horizon can only go inward, never to return. But the comparison to a waterfall falls short of capturing the true nature of this boundary. Unlike water, which we can at least see flowing over a waterfall, the event horizon represents a threshold where even light itself surrenders to gravity's overwhelming power. To better grasp the concept of the event horizon, consider a spacecraft approaching this boundary. As it gets closer, it would need to travel faster and faster to resist the black hole's pull. At the event horizon itself, it would need to travel at the speed of light to escape, something that's physically impossible for any object with mass. This is why we say nothing can escape from beyond the event horizon. It's not just a matter of being strong enough or having a powerful enough engine. It's a fundamental limit imposed by the laws of physics themselves. But the event horizon is just the beginning of our journey into a black hole's anatomy. At the center lies something even more mysterious and profound, the singularity. This is where our understanding of physics breaks down completely. Imagine taking all the mass of several stars, billions of tons of matter, and compressing it into a point smaller than the smallest atom. In fact, according to our current theories, the singularity isn't just very small, it's infinitely small, with infinite density. It's a concept so extreme that our mathematical models simply cannot describe what happens there. To try to visualize the singularity, think about squeezing an entire ocean into a single drop of water, and then squeezing that drop into something infinitely smaller. But even this analogy falls short because the singularity isn't just about extreme density. It's a place where space and time themselves become so warped that our normal concepts of here and now lose their meaning entirely. Between the event horizon and the singularity lies a region of space where reality becomes increasingly distorted. Time slows down dramatically relative to the outside universe. If you were to watch a clock falling into a black hole, it would appear to tick more and more slowly as it approached the event horizon, eventually appearing to freeze in time altogether. For the object falling in, however, time would seem to proceed normally, while the outside universe would appear to speed up dramatically. The space around a black hole is also warped in extraordinary ways. The massive gravitational field bends light rays, creating what astronomers call a gravitational lens. This effect can cause light from distant stars to appear in different positions, or even create multiple images of the same object. The closer you get to a black hole, the more extreme this warping becomes, until at the event horizon, space itself becomes so curved that all paths lead inevitably toward the singularity. These features make black holes not just objects in space, but rather regions where space and time themselves behave in ways that challenge our most fundamental understanding of the universe. They represent the ultimate laboratory for testing our theories about gravity, space, time, and the nature of reality itself. Now, I can't help but wonder, what do you think would happen if you fell into a black hole? Would you be stretched into an infinite string by the tidal forces? Would you see the entire future of the universe flash before your eyes as time distorts around you? Share your theories in the comments below, and don't forget to give this video a like to help others discover these fascinating cosmic mysteries. Your engagement helps us continue exploring the most mind-bending phenomena in our universe. Let me take you through one of the most groundbreaking moments in astronomical history, the day humanity finally captured an image of a black hole. In April 2019, the world stood still as astronomers unveiled an achievement that many had thought impossible: the first ever direct visual evidence of a supermassive black hole. The image, captured by the Event Horizon Telescope, was the result of an extraordinary collaboration involving over 200 scientists and 8 interconnected telescopes spread across the globe. This network of telescopes effectively created an Earth-sized observatory, capable of unprecedented precision in viewing distant cosmic objects. The target was M87, the supermassive black hole at the center of the Messier 87 galaxy, located approximately 55 million light-years away from Earth. What makes this achievement even more remarkable is the immense technical challenges that had to be overcome. The black hole, despite its massive size, about 6.5 billion times the mass of our Sun, appears incredibly small from Earth due to its enormous distance. Photographing it was equivalent to trying to photograph an orange on the surface of the Moon from Earth. The amount of data collected was so vast that it couldn't be transmitted over the internet. Instead, hard drives had to be physically transported between observatories. The resulting image showed exactly what Einstein's theory of general relativity had predicted over a century ago: a bright ring-like structure surrounding a dark central region known as the shadow of the black hole. This bright ring is created by superheated gas and dust swirling around the black hole at nearly the speed of light, emitting intense radiation just before being consumed. The asymmetric brightness in the ring also confirmed another prediction: that material orbiting the black hole would appear brighter on the side moving toward Earth due to relativistic beaming. But here's where many people get confused. If black holes are completely dark, how did we manage to photograph one? The answer lies in what we're actually seeing. We're not seeing the black hole itself. That's impossible, since it absorbs all light. Instead, we're seeing its silhouette against the bright background of hot material surrounding it. It's similar to seeing the dark shape of a person standing in front of a bright window. You're not seeing the person directly, but rather their shadow against the light. The image provided much more than just a spectacular view. It offered concrete evidence for several key theoretical predictions about black holes. The size and shape of the shadow perfectly matched what Einstein's equations had predicted, providing one of the most stringent tests yet of general relativity under extreme conditions. The image also revealed details about how matter behaves in the most extreme gravitational environments in the universe. In the years since this groundbreaking image, the EHT collaboration has continued its work, capturing images of other black holes, including Sagittarius A, the supermassive black hole at the center of our own Milky Way galaxy. Each new image adds to our understanding of these cosmic giants and helps confirm or challenge our theoretical models. This achievement represents more than just a scientific milestone. It's a testament to human ingenuity and collaboration. It shows how far we've come from the days when black holes were merely theoretical curiosities to now being able to actually see these mysterious cosmic objects. The image serves as a bridge between the theoretical and observational aspects of modern astronomy, confirming centuries of mathematical predictions and opening new avenues for research into the nature of gravity, space, time, and the evolution of galaxies. The fact that we can now visualize these cosmic monsters marks the beginning of a new era in astronomy. As our technology continues to improve and our understanding deepens, we can look forward to even more detailed images and discoveries about these fascinating objects that continue to captivate both scientists and the public alike. Let me reveal a profound truth that challenges our common understanding of black holes. Far from being mere cosmic vacuum cleaners, mindlessly consuming everything in their path, black holes are among the most fundamental and fascinating architects of our universe, playing roles that continue to astound astronomers and theoretical physicists alike. First, let's address their crucial role in galactic formation and evolution. At the heart of virtually every major galaxy we've observed, including our own Milky Way, lies a supermassive black hole. These cosmic titans, millions to billions of times more massive than our Sun, act as gravitational anchors that help shape the entire structure of their host galaxies. The intense gravitational forces they exert influence the movement and distribution of stars, gas, and dust, effectively orchestrating the cosmic dance that gives galaxies their characteristic spiral or elliptical shapes. These supermassive black holes also regulate star formation within their galaxies through a process astronomers call feedback. When they actively consume matter, they release enormous amounts of energy back into their surroundings, creating powerful winds that can either trigger star formation by compressing gas clouds or suppress it by blowing material away. This delicate balance helps explain why galaxies don't simply collapse into their centers and why they maintain their beautiful, stable structures over billions of years. But perhaps even more intriguing are the theoretical possibilities that black holes present. Some of our most respected physicists, including Stephen Hawking and Kip Thorne, have proposed that black holes might serve as gateways to other universes or distant parts of our own universe. This concept, known as wormholes or Einstein-Rosen bridges, suggests that the extreme warping of space-time within black holes might create tunnels through the fabric of reality itself. While this remains firmly in the realm of theoretical physics, the mathematics behind these ideas are sound enough to warrant serious scientific consideration. Black holes also serve as natural laboratories for testing our most advanced theories about the universe. They are places where the two fundamental theories of modern physics, quantum mechanics and general relativity, come into direct conflict. In the extreme conditions near a black hole's singularity, our current understanding of physics breaks down completely, suggesting that there must be a deeper, more fundamental theory waiting to be discovered. This makes black holes invaluable tools for theoretical physicists working to develop a theory of quantum gravity, often considered the holy grail of modern physics. The study of black holes has led to revolutionary discoveries about the nature of space, time, and gravity. Through them, we've learned that space and time are not fixed and absolute, but can be stretched, warped, and even torn. The recent detection of gravitational waves from colliding black holes by LIGO has opened an entirely new field of astronomy, allowing us to hear the universe in ways we never could before. Moreover, black holes have taught us about the fundamental connection between information and physics through the black hole information paradox. This puzzle, which asks what happens to information that falls into a black hole, has led to groundbreaking insights in quantum mechanics and may hold the key to understanding the very nature of reality itself. Looking ahead, black holes continue to offer new mysteries to solve. Recent observations have revealed pairs of supermassive black holes orbiting each other at the centers of merging galaxies, providing us with natural laboratories for studying gravity under the most extreme conditions imaginable. The upcoming generation of telescopes and gravitational wave detectors promises to reveal even more secrets about these enigmatic objects. In essence, black holes are not destroyers, but creators, not endpoints, but gateways to new understanding. They are fundamental to our universe's structure and evolution, possible portals to new realms of existence and windows into the deepest mysteries of physics. As we continue to study them, they challenge our assumptions, expand our understanding, and remind us that the universe is far more extraordinary than we ever imagined. These revelations show us that black holes are not just passive objects in space, they are active participants in the cosmic story, helping to write the rules that govern our universe and potentially opening doors to new realms of physics and astronomy that we are only beginning to understand. As we conclude our journey through the mysterious realm of black holes, we find ourselves standing at the edge of human knowledge, much like an observer at the event horizon of these cosmic giants. Black holes serve as a humbling reminder that our universe holds secrets far beyond our current understanding, continuously challenging our most fundamental theories about reality itself. From their violent births in the death throes of massive stars to their crucial role in shaping galaxies, black holes exemplify the dynamic and interconnected nature of our cosmos. They represent places where the familiar laws of physics break down, where time itself behaves in ways that defy our everyday experience, and where the line between the possible and impossible becomes increasingly blurred. The recent breakthroughs in black hole observation, particularly the historic first image from the Event Horizon Telescope, mark not an endpoint, but rather a beginning of a new era in astronomy. Every answer we uncover seems to lead to even more intriguing questions. Are black holes truly the information destroyers they appear to be, or do they preserve the information of everything they consume in some yet unknown way? Could they really serve as gateways to other universes or different regions of our own space-time? The possibilities are as endless as they are fascinating. Perhaps most importantly, black holes remind us of the extraordinary nature of scientific discovery itself. A century ago, these objects existed only in the mathematical equations of Einstein's theory. Today, we can not only confirm their existence, but study them in unprecedented detail, showing how human ingenuity and determination can unlock the deepest mysteries of the cosmos. But our exploration doesn't end here. In fact, we're just getting started. In our next video, we'll delve into one of the most exciting developments in modern astronomy: gravitational waves. These ripples in space-time allow us to hear the universe in an entirely new way, particularly when massive black holes collide. We'll explore how scientists use incredibly sensitive detectors to measure these cosmic vibrations and what they're teaching us about the violent events that create them. Don't miss this next chapter in our cosmic journey. Join our growing community here at Exploring the Universe by subscribing to our channel and turning on notifications. Each week, we venture further into the unknown, uncovering the secrets of our extraordinary universe. From quantum mechanics to dark energy, from the birth of stars to the death of galaxies, we're here to explore it all with you. Remember, every time we look up at the night sky, we're not just seeing points of light. We're witnessing a cosmic drama that has been unfolding for billions of years. And black holes, those mysterious cosmic giants, are among its most captivating players, reminding us that reality is far more extraordinary than anything we could have imagined. So stay curious, keep questioning, and join us next time as we continue our exploration of the greatest mysteries in the cosmos. The universe is calling, and its stories are waiting to be discovered. Click that subscribe button now, and let's embark on this amazing journey together. Until next time, keep looking up and wondering about the extraordinary cosmos we call home.